Inshallah, today class we are going to learn about we are going to do the questions based on exact differential equation. The necessary and sufficient condition for m dx plus n dy equals to 0 to be exact. You see here, the condition for exact differential equation is dou m by dou y equals to dou n by dou x. We have to verify, we have to find dou m by dou y and dou n by dou x. If they both are equal, then we say that the equation is exact. Okay, before going to the formula, let me see one thing, little examples I wrote. Okay, you see here, we already know. Those who don't know, they just revise this one. D by dx of x is 1, d by dx of x square is 2x, d by dx of x cube is 3x square. Similarly, d by dx of x power 4 is 4x cube. And this also we have to by heart this one. D by dx of 1 by x is minus 1 by x square. D by dx of 1 by x is minus 1 by x square. Now see here, suppose example we are going to do now. Suppose we are having m equals to x square plus y square. If we do partial differentiation, you write dou m by dou x with respect to x. Dou m by dou x. When we do with respect to x, we feel that y is constant. We take y constant. So d by dx of x square is 2x. Dou n by dou y. Suppose we are differentiating partially with respect to y. Then d by dx of y cube is 3y square. We don't differentiate x. We write x as it is. D by dx of y cube is 3y square. So 3 is come here. 3 to the 6 y square. In the same way, dou by dou y, dou m by dou y is in the denominator. That is, this is 1 by y. 1 by y. So d by dx of 1 by y is minus 1 by y square. So for exact differential equation, the solution is, we have to by heart this formula. For exact differential equation, the solution we write like this. In the solution is integration of m dx plus integration of n dy equals to c. The solution for exact differential equation is integration of m dx plus integration of n dy equals to c. Here when we take m, we consider y as constant. Y constant. When we integrate m, we feel y as constant. And when we take n, we cannot take all the terms of n. We take the terms of n which do not contain x. Terms of n which do not contain x. Do not contain x. Or we can say as terms free of x. Terms free of x. So let me do questions on these types. Now see here, one question I wrote on the board. I written on the board. See here, d by dx of e power x equals to e power x. D by dx of x square is 2x. D by dx of x is 1. These are the formulas we are going to use here. Now first you compare this with the general equation m dx plus n dy equals to 0. Whenever we get the question like this, first we have to compare with this general form. So write what is the value of m. The value of m is 3x square plus 2e power x, and the value of n is 2x e power y plus 3y square. The initial step is we have to see whether this is exact or not. For that, what is the condition we have? Dou m by dou y equals to dou n by dou x. So let me find dou m by dou y and dou n by dou x, then let me compare it. Okay, so let me write differentiation partially with respect to y. When we differentiate partially with respect to y, we consider x as 0, constant. So the differentiation of constant is 0. Here the question is 3x square plus 2e power y. Sorry, this question is 2e power y. 2e power y. Okay, so let me differentiate with respect to y, because we don't have y here, it's constant 0. Now 2 as it is. D by dx of e power y is e power y. Now come here, Let me differentiate this with respect to x. So we write dou and partially differentiation with respect to x. So when we differentiate with respect to x, we feel y is constant. We take y as constant, so this will be 0. Here d by dx of y is constant, d by dx of x is 1, 2 into 1 is 2, 2 e power y. With respect to x, x is 1, 2 into 1 is 2 e power y. We don't have x in this term, so it is constant. So constant differentiation is 0. So we got the same. Therefore, dou m by dou y equals to dou n by dou x, implies, you know, it is exact differential equation. So for exact differential equation, we use the formula. What is the formula we have? Integration of m dx plus integration of n dy equals to c. Here in m, we take y constant. Here in m we take y constant, and n terms we take only terms do not contain x. Do not contain x. So let me take this one, integration of m. You take m, complete m. So it will be 3x square plus 2 e power y dx plus integration of, you see here, integration of n. We do not take all the terms of n. We have to take the terms of n which do not contain x. Because it contains x, we do not take n. We take the value of n only the terms which do not contain x. See, we have to take only 3y squared equals to c. Now see here, let me see, I'll explain one thing. Suppose you are having 2 e power y integration d. Here you see how to change this one. Watch carefully, we are integrating with respect to x. We don't have x here, so we must fill that integration of 1. We can take this out. So if you take out this one, we left with 1. So integration of 1 will be x. So this one we have to integrate like this. Whenever you get constant, we must suppose that as 1. So integration of 1 is always remember x. Integration of 1. Integration of 1 is x. Now see here, we are integrating with respect to x, implies the integration of x is square is x square is integration of x square is x power n plus 1 by n plus 1. So 2 plus 1 is 3 by 3. See here, we don't have x here, that is this is constant, so we must fill integration of 1. Integration of 1 will be x, so we get 2x e power y plus 3 as it is. Here we are integrating with respect to y, integration with respect to y. So integration of y power n plus 1, 2 plus 1, 3 by 3 equals to c. We know integration of x power n is x power n plus 1 by n plus 1. So this is the last step. Now let me cancel this 3 3. So we got the answer as x cube plus 2x e power y plus y cube equals to c. So this is the procedure of doing the question. Now let me try one more question here. So see, compare this as m dx plus n dy equals to 0. So we have m, the value of m. The value of m is x squared minus 4xy minus 2y squared. So value of n is y squared minus 4xy minus 2x squared. Now first we see whether it is exact differential equation or not. So see here, let me do one thing. I'm differentiating this with respect to y, dou m by dou y with respect to y. We don't have y here, so it is 0. D by dy of y will be 1. 1 into minus 4x minus 4x minus integration of y, sorry, differentiation of y square will be 2y. So 2 into 2, 4y. Watch here, we are doing partial differentiation with respect to y. We don't have y here, so it's 0. D by dy of y will be 1 into minus 4x minus 4x. Y square is 2y, 2 roots of 4y. Let me integrate, let me differentiate here dou n by dou x with respect to x. We don't have x here, so it will become 0. Now d by dx of x is 1. 1 into minus 4 is minus 4y. Now integration, differentiation of x square is 2x, so 2 to the 4x. Now we get the same values of this both. We get the same values of this both. So therefore, dou m by dou y equals to dou n by dou. Now this is implies exact differential equation. Now for exact differential equation, we have the formula for exact differential equation. The formula is integration of m dx plus integration of n dy equals to c. In m, we take y constant. Y constant. In x, in n we do not take all the terms. We take terms only which do not contain x. Which terms which do not contain x. Do not contain x. So let me continue here. Integration of m. You take all the values of m. Integration of m, you take all the values of m. So what is m? X square minus 4xy minus 2y squared dx plus integration of, when we take the here n, we have to take only terms which do not contain x. This contain x, so we do not take. This value also contain x, so we do not take x. So the only term left is y square dy equals to c. Now let me continue here. Equals to, now integration of x power n is x power n plus 1 by n plus 1. So 2 plus 1 3 by 3 minus 4 into integration of x power 1, x power n plus 1 by n plus 1. 1 plus 1 is 2 by 2. We feel y as constant. Now just to explain, we are integrating with respect to x. So we don't have here x. We don't have here x. So we must take as 1. Integration of 1. Integration of 1 will be x. Here it is constant. So integration of constant, that means we take only 1. Integration of 1 is x. So 2 into x is 2xy square plus integration of y square is y cube by 3 equals to c. Now we can leave here, or if we want we can take LCM. 2 ones are 2 twos. Now if we take LCM, we are having 3 here. If we take LCM, this 2 will get multiplied with 3. So I am taking LCM here. See here, 3 3 as it is, x square x cube minus 3 twos are 6. 6x square y minus 3 twos are 6xy square. Now lastly y cube plus y cube equals to 0. Plus y cube equals to c. Now bring this c here, bring this 3 here. Now 3c is also another constant. We just take some another constant for here. So it is x cube minus 3x square y minus 3xy square plus y cube equals to, if you bring this 3 here, it will be 3c. 3c is a constant. Let me take some other constant k. Okay. Now the next question is see here. First let me change into the form m dx plus n dy equals to 0. For that you bring this number, bring this term on the other side, it will become minus. You see here, dy by dx equals to, plus term on the other side minus y cos x plus sin y plus y divided by sin x plus x cos y plus x. Now you do one thing, you cross multiply this one, it will come here and this will go here. I'm cross multiplying this one, so this will be sine x plus x. The next step, we bring the minus term on the right side, it will become plus. If you bring here minus, it will become plus. So first you write this m dx plus n dy. So first we write n y cos x. Now you compare with the general equation m dx plus n dy equals to 0. So what's the value of m? Therefore we have m equals to y cos x plus sine y plus y, and n we have sine x plus x cos y plus x. Now let me see whether it is exact or not. For that we have to find dou m by dou y and dou n by dou x. If these both are equal, then we say that this is exact. Now with respect to y, here see the differentiation of y is 1. 1 into cos x will be cos x plus d by dx of sine will be cos, so this will be cos y. Now d by dx of x is 1, similarly d by dy of 1 will be 1. Now come here with respect to x, d by dx of sine will be cos x plus d by dx of x will be 1. 1 into cos y will be cos y, d by dx of x is 1. We are partially differentiating here with respect to x and here with respect to y. Now we got this both same. We get this both same. Therefore, dou m by dou y equals to dou n by dou x. It implies it is exact differential equation. It is exact differential equation. Therefore, for exact differential equation, we have the formula m dx plus integration of n dy equals to c. Now what we take here? We take here y as constant. Y as constant. What we take here? We take the terms of n which do not contain s. Which do not contain x. Do not contain x. I'm writing in short, okay? So let me write m. We take all the terms of n. M. But while differentiating, integrating, we consider y as constant. So right, let me write it. So sorry, what is y m here? We are having m y cos x plus sine y plus y dx plus integration of m n. So here you see here integration of n. We have to take only the terms which do not contain x. This term contains x. This term also contain x. This term also contain x. So we don't have any term which is independent of x. So we write just 0 dy equals to c. You already know that what is the integration of sine x. Integration of sine x is minus cos x. In the same way, integration of cos x. Integration of cos x is sine x. So let us substitute here the last step. We are integrating with respect to x and considering y as constant. So y you write as it is. Now integration of cos will be sine. Integration of cos will be sine. Now you see here we are integrating with respect to x. We don't have x here. So just now explain, whenever there is a constant, we must feel we are having 1 here. So integration of 1 will be x. So this will become x sine y. Plus here also we don't have x, we have to integrate with respect to x. So y is constant. With constant we feel we take with constant 1 for integration. Integration of 1 is x, like this. Integration of y dx. If you bring out y outside, we left with 1. So integration on 1 will be like x. So this will be xy equals to c. Now see here, next question. I wrote some steps before itself. Solve the initial value problem. This is the problem. You see here, y of 1 equals to 2. This initial value problem is, I'll explain this afterwards. This condition is given to find the value of c at last. After solving completely the question, when we use this condition, we'll get the value of c. Now see here, compare with m dx plus n dy equals to 0. So the value of m is 3x square y power 4 and the value of n is 4x cube y cube. We already know the differentiation of x power 4 is 4x cube. Integration of x cube is 3x square. So let me see here. Let me see. Integration d by dx of x cube is 3x square. D by dx of x power is 4x cube. Now let me differentiate. First we see whether it is exact or not. For that we have to differentiate partially m with respect to y. Dou m by dou y. So d by dy of y will be y power 4 is 4y cube. 4y cube. If we bring here 4, 4 3s are 12y cube. Now with respect to x, x cube is 3x square. If we bring 3 here, 12x square. So we got the same values. Therefore, dou m by dou y equals to dou n by dou x. It is exact differential equation. For exact differential equation, we have the formula integration of m dx plus integration of n dy equals to c. In m we take y, consider y as constant, and n we do not take the terms containing x. So see here, integration of m, we take all the values of m, but when we have to take value of n not containing x, we are having only one term which contains x, so it will become 0. Now here we have to integrate with respect to x and take y as constant. So 3 into integration of x power n is x power n plus 1, 2 plus 1, 3 by 3. You write y power 4 as it is. Now this is constant, this is sorry 0, it will become 0 c. This 3 will get cancelled. So what is left here? X cube y power 4 equals to c. So the initial value is given. Using this initial value, y of 1 equals to 2, we have to find c. Y of 1 equals to 2. What does it mean? The value of x is 1, the value of y is 2. We write like this, y of x. So x is 1 and this value is y. Therefore, substitute x equals to 1, y equals to 2. In this one, in place of x1, so this will be 1 cube. In place of y2, 2 power 4 equals to c. Therefore, c equals to 2 power 4 is 16. Got it? Here, what we have to do, this value will be x value, this value will be y value. So we substitute here, we got c. Therefore, the solution is x cube y power 4 equals to c is 16. So let me complete this class now. This question, inshallah, we are going to see the other types of exact differential equations where we have to find the integral factors. Let me continue that in the next class. We will see the different types of exact equations which we can change into exact form. Okay, so let me continue in the next class. So I request you all to subscribe my channel and like and share with your friends. Inshallah, we are going to continue in the next class.